All right, so today we'll start chapter 11. Okay, so chapter 11 is on two topics, the ones we're going to look at. The first topic is called a sequence. The second topic is called a series. Okay, we won't look at what a series is until tomorrow. But kind of really quick, a series is when you add up all the numbers in a sequence. That's a series. Today, we're just going to put commas between the numbers. We're just going to write them all out. We're not going to add them up today. So, a sequence of numbers is some set of numbers that has a certain order to it. Okay, it has to have a pattern. And usually we name a sequence with a lowercase letter. Okay, we could just call it sequence B or sequence A. Here's a sequence of numbers. The first one is 1, 1/2, 1/3, 1/4. What would the next term be in that sequence? 1/5. Does anybody see what the sequence is approaching? Like if you continued it forever.
0.
It's approaching 0. The number is getting smaller and smaller and smaller. It'd be like the, 100th term would be 1/100th. The millionth term would be 1/1,000,000th. So it's getting very, very, very small, but it's actually never reaching 0. And the way we identify the terms in a sequence, we say B sub 1 is the first term in sequence B. B sub 2 is the second term. B sub 3 would be the third term. B sub n would be the nth term. There's two main types of, there's different ways you can classify sequences. But what I'm thinking right now, there's two types. There's sequences that are infinite, meaning they never end. And then there's sequences that are finite. This is an infinite sequence. Does anybody know how I know that? It has to do with something that's on the board. Yeah?
It does not have an end iteration, it just has a variable.
Okay, and how do you know it doesn't end? What tells you that it doesn't end here? The dot, dot, dot. Tells you it keeps going. Okay, if I drew this, and I just said, here's a sequence, maybe this is a sequence of just 4 terms, and that's it. Okay, but if you put a dot, dot, dot on it, that usually means that it keeps going forever. Kind of like when they write pi. They put an ellipsis, that's what it's called, because it keeps going. Okay. In order for a sequence to be unique, there has to be a rule to calculate any term in the sequence. There has to be a pattern to it. Now, this sequence isn't bad. If I asked you for the 10,000th term, you could just say 1/10,000th. It's not a very complicated sequence. But sometimes sequences are much more complicated. So we want a pattern, a rule, to help us calculate any term we would like to know. And we're going to come up with ways to figure out patterns, but I just want to see if you can look at that one and figure out a pattern or a formula that could give me any term that I want to know. So if you recognize what arithmetic operation you're doing, then we have to turn that into a formula somehow. Yep?
A(n plus 1 equals a(n plus 3).
So the nth term equals, can you say it again?
N plus 3. A(n equals a(1).
How about, can you word it in words? And then we'll worry about how we write it in symbols.
Current integer, next integer in line is 3 plus the current integer.
All right, so to get the next one, you take the previous one and add 3. That's the pattern. So if you're looking for a sub n, How do you think you would write the one before a sub n? Yes, a sub n minus 1. So the formula, or one of the formulas here, is to take the, if you want to know a term, take the one before it and add 3. Now, there's a disadvantage to that formula. What if I wanted to know the 100th term? I don't have the one before it. What would that one be? Well, it would be the 99th term. So I need that one. But then, what other term do I need? I need the 98th. But to get that one, I need the 97th. I need the 96th. So this kind of formula relies on you knowing every single term up to the one you want. There's another way we could write the formula where that wouldn't be true. Think of the numbers I'm writing above as term numbers. First term, second term, third term, fourth term. Does anybody see a way you could just take the number 3 somehow and turn it into an 8? And then take the number 4, turn it into an 11. You got to do the same arithmetic. There's an arithmetic operation you can do, like double it and add 1, or quadruple it and subtract 5 each time. But there's a pattern here. N squared. Well, that works here. If you square 1, you get 1, and add 1, you get 2. It works here. If you square 2, you get 4, and add 1, you get 5. But if you square it here, you get 9, and if you add 1, you get 10. So that formula kind of breaks down after the first couple.
You gotta multiply by 2, and it's gonna increase you have to add,
We have to add the same thing every time.
oh, you do?
Yeah.
Is it n times 3 minus 1?
Yes.
Oh, okay. I got it.
Is that what you're going to say, Sam?
Yes.
Yeah. If you want to know the nth term, all you have to do is take the term number you want to know, say the 10th term, triple that and minus 1. So if I wanted the 10th term, it would be 29. 10 times 3 is 30, minus 1 is 29. Let's check it here. The 4th term. What's 3 times 4? Minus 1? Oh, there's the 11. Let's try the third one. 3 times 3 is minus 1? Here's your 8. So this type of formula is a better one if we can come up with that, because it doesn't rely on knowing any terms before it. I could just find the 200th term. What would the 200th term be? $5.99. Yep. So we can just find the 200th term, and we didn't have to find every term before it. Okay? I'll explain what those two are called. There's names for each one of these. Okay? All right, so next I'm going to talk a little bit about the two types of sequences I mentioned earlier. Infinite sequence. Basically means you have a function where the domain is all positive integers. So if we take a look at this formula that I just circled, if I'm saying it's an infinite sequence, what that means is you can plug any number you want in for n, as long as it's a positive integer. Why wouldn't n ever be negative when you're talking about terms in a sequence? Well, what does n represent here?
Term number?
The term number, the place in the sequence. So why wouldn't n be negative? Yeah, you don't have a negative third term. You don't have a negative fifth term. You don't have negative terms. You start at the first term and you go up. How come n wouldn't be a decimal? Yeah, terms are whole numbers. You're either second term or third term. There's no such thing as the 2.7th term. There's a second term and there's a third term. So in that sense, you only can use positive integers. Okay? And if it's an infinite sequence, you can use any positive integers you want. If it's a finite sequence, then the domain has a limit. You can only go up to a certain value. Right? If you had a sequence with 10 terms, then n would be 10. That's the highest number you're allowed to plug into the formula. Okay, so in a finite sequence, the domain is limited. It's a subset of positive integers. Okay, so any question on the difference between an infinite sequence and a finite sequence? Okay, this is kind of getting at what we're going to look at tomorrow, but what do you think would happen if you add up infinitely many numbers? Do you think you would get an answer? Yes, no, or does it depend? Yeah, if you were to take a sequence of numbers and that was infinitely long and add them all up, what do you think would happen?
Wouldn't this be infinite?
It could be, sometimes. If you had a sequence like this, 2, 4, 8, 16, 32, and you add up all those numbers, and if it kept doubling forever, each term, and you add them all up, yeah, it would approach infinity. How about if you had a sequence like this, though? 1/2, plus a third, plus a fourth, plus a fifth. What's happening with each number that I add as I go? It's decreasing. It's getting smaller and smaller. So the question of if you add up infinitely many numbers, what happens? The answer is it depends. Are you adding up numbers that just get bigger and bigger all the time? Or are you adding up numbers that each time you add one, it's getting smaller and smaller and smaller what you add, till eventually you're adding something so small, does it even make a difference anymore? So we'll look more at that question tomorrow. But that's kind of where we're going when we talk about infinite sequences. And of course, if you have a finite sequence and you add up all the numbers, you always get a number. Because a finite sequence has a beginning and it has an end. So if you add up something with a beginning and an end, it's going to end somewhere. All right, so in this problem, I've given you a formula. It says a sub n equals n squared minus 1 over n, where n is the term that you're looking for. So I want to know the first 3 terms, and then we'll skip to the 15th term. Okay, to find the first term, what would you plug in for n? 1. Let's do it. So we get 1 squared, which is how much? 1 minus 1. So 0 in the top, divided by 1 in the bottom. So what's the first term in the sequence? So what I'm going to do is I'm going to teach you, if you can figure out what the common difference is, get the formula. It's always the number that's added onto the end. I can teach you how to write it explicitly without even really thinking about it. So the way John was figuring out some of these, oh, well, it's like times 5 minus 2. I'm going to show you a way to figure that out automatically without trying to use any reasoning. Okay, you just use this formula.
I thought it had something to do with the adding.
Yeah, it does. So
I was figuring out by saying, so if it was add 5, I was like, oh, it must be multiplied by 5, and then we just figure out what from that 5.
take into account the first term.
Yeah.
Yeah, and that's exactly what the formula is. It's the same type of thinking. You take the first term plus n minus 1 times d. So it's basically like you're multiplying how many times you added the number minus 1 time, because you don't count the first one. So it's how many times after the first one did you add 5 plus the first term. Okay, that's basically the idea. Because as long as you're adding the same thing over and over and over, it's really just multiplying. right? How many times did you do it? 4 times, whatever. And this just means n is an integer. Okay, n has to be a positive integer. So no decimals, no fractions, no negatives. Okay, so let's keep that formula in mind. A sub 1 plus n minus 1 times d.
Now, if it was subtraction, would it be division?
It would just mean d would be a negative here.
D would just be.
Yep. How many times did you add negative 5? That's really like subtracting. Yep. So remember, the common difference is always you take any term and subtract the one before it. That's how you find the common difference. If I just listed a bunch of numbers like this, 2, 6, 10, 14, 18. Pick any term you want, subtract the one before it, and then you can see what I added each time. And if I didn't add the same thing each time, then it's not an arithmetic sequence. Okay, so let's write an explicit formula for this. Okay, what comes first for that formula I just gave you on the other page? A1. So what would the, I have to give you A1 here. Let's just make something up. If I don't give you the first term, you can't do it. Let's let A1, sure. Okay, A1, first term is 9. So,
Really?
9. Plus, what comes next? N minus 1 in parentheses times the common difference. Now, we don't have the sequence listed out, but if you know where to look, the common difference is written on the board. What is it? 3. Now, generally, we don't leave the formula like that. You can simplify that. What do you have to do with the 3? Distribute it. So what do you get when you do that? 3n minus 3, which means our formula is going to be 3n plus 6. So basically the pattern here is you're going to triple the number and add 6. And if we wrote that out, you would see it. Okay, I'm not going to write it out, but that is the pattern. Any questions on that? So a sub n equals the first term plus n minus 1 in parentheses times d. And again, that's for an arithmetic sequence. What does that mean? It means to get to the next term, you add something to the previous term, or subtract. Add or subtract. Okay, so you've got to make sure you have an arithmetic sequence before you use this formula. So any question on what an arithmetic sequence is? It's adding and subtracting to get to the next term. That's the pattern. Okay, first two terms of an arithmetic sequence are -8 and -2. Let's find the fifth term. Okay, let's come up with a formula. So what would be the formula for this arithmetic sequence? What do we put first? Oh, John?
So those are the first two at the top.
Yep.
Well, usually starts with and minus 1.
Not for an explicit formula.
Explicit. The difference is
We're using this right here. So what's a sub 1?
-8
So we start with -8.
plus n minus 1.
Yep. And what's the common difference here?
6.
6. Yep. We're adding 6 each time. So if I did that out, it's -n plus 6n minus 6. Or 6n minus 14. So, now I can find the fifth term without finding all the ones before it. What's 6 times 5? 30 minus 14. 16. What's that? Now, I probably could have found the fifth term faster by maybe adding 6, and then adding 6 again. But if I said to find the 600th term, I wouldn't want to keep doing that. So formula makes it a little faster. Okay. Any questions on that? All right, so I think we're just about done. All right, same kind of problem here, but this time they give me the third term and the 8th term. So how could what term do I really need to figure out? I need the first one. But what do I know about going to each term? Each time I make a jump, what's happening?
It's smaller.
It's getting smaller, so I know I'm subtracting. And I have to subtract. What about the amount I subtract each time? It has to be what? You don't have to tell me a number, but it has to be.
Maybe too big. Obviously.
Well, how about the calculation you do to get from here to here versus from here to here? How will those calculations compare? They'll be the same. That's the key. You can't subtract 1 and then say, oh, now I'm going to subtract 6. You have to do the same thing every time. So what would you have to subtract equally to get from 13 to 3? How much? Oh, yeah, so we have a difference of 10, and we have 1, 2, 3, 4, 5 jumps to make. So how much, if you divide it out? Yeah, 2 per jump. So 11, 9, 7, wait a minute, 5, 3. So if I wanted to get back to the first term, well, just do the jumps in the opposite direction. 15, here's your first term, 17. So a sub n equals 17 plus n minus 1. What's my common difference here? Negative 2, because it's going down. And now just do that out. 17 minus 2n plus 2. So 19 minus 2n. A little bit different of a problem, but not really that much different. You just have to kind of think of the first, you figure out how to get the first term. Okay, and the last, so the last type of sequence we're going to look at is called a geometric sequence. So arithmetic, you add each time, or subtract. Does anybody know what's going to happen in a geometric sequence? Yes, so something like 2, 4, 8, 16, 32, 64. That's multiplying by 2 each time. We'll see in a second. It's not that bad of a formula. It's about as difficulty-wise the same as the first one, but just different. So this is how you can think of it recursively. To get the next term in the sequence, take the term before it and multiply by r. Okay, so to get the next term, take the one before it and multiply by r. R is called the common ratio of the sequence. So we had something like this. 2, 4, 8, 16, 32. What's 32 divided by 16? 2. What's 16 divided by 8? 2. 8 divided by 4? 2. So if you take a term and divide it by the one before it, that's the common ratio. Take a term, like 16, divide by the one before it, like 8, and that'll tell you r is 2. Okay, so the last thing I'm going to give you is what John was mentioning. How do you write this explicitly? Well, when we do, does everybody have up to that step? Okay. When we do repeated addition of the same thing, that's called multiplication. You do plus 5, plus 5, plus 5, plus 5. That's just 5 times 4, or however many I said. What if you do repeated multiplication of the same thing, like 2 times 2 times 2 times 2? That's a power. So this formula has a power in it. So to figure out explicitly the nth term of a sequence, you have to figure out how many times did you multiply the first term by your common ratio. And you do it one less than the term number because you don't count the first term. So like if I wanted to find the fourth term in a geometric sequence, I would say, okay, what did I multiply by? And to get to the fourth term, you do it 3 times. Think about it. First term, how would you get to the fourth term? You would multiply 1, 2, 3 times. So 3 times to get to the fourth term. That's why there's a -1 there. And it's times the first term. So you got to know the first term, and then you're good. Okay, so the last problem we'll do will be an example of a geometric sequence. Okay, whether it's arithmetic or geometric, what term is the key term you got to know? You got to know the first term. So we got to have to work backwards here. How do I get from 12 to -6? What did I do? Divide by -2. So do the same thing to get back to here. What did you do? What would you get? 3. Okay, so if we follow our formula, a sub n equals a sub 1 times r to the n minus 1. What is the common ratio here? -2. Let's just try it on one of them. Third term. What's 3 minus 1? 2. What's -2 squared? 4 times 3. There's your 12. Let's try the second one. What's 2 minus 1? 1. What's -2 to the first? -2 times 3. There's your -6. So if you wanted to know, let's try one we don't know. Fourth term, what's 4 minus 1? 3. What's -2 cubed? -8 times 3. -24. So it works. Okay. So any questions on a geometric sequence? Okay, so just write down the 2 explicit formulas and you're pretty much good to go. All right, so homework, it's all odds except for 14. So on 589, 1 to 5 odd, 9 to 13 odd, 14, that's even, then 17 to 27 odd, and 31. Okay, so tomorrow we will start our last section. Okay, that'll be the last section we do in the course, 11.2. And we're going to split that section into 2 days. Also, as far as extra help this week, I think I'm going to stay Wednesday this week for extra help. Okay, so if you want to come by for extra help, as of right now, I'm definitely going to stay Wednesday. If I could stay Thursday, I'll let you know.